look at solving rational equations. So use your highlighters with me. And a rational equation is where you have a quotient of two polynomials. So in example A, we're going to start with a proportion, and let's define that. A proportion is when you have one fraction equals one fraction, and then the restrictions are where the denominator can't be 0. So go ahead and jot that down. We're going to start off with a proportion is an example of a rational equation. So in order to solve it, you're going to cross multiply, but before you do, you need to check your restrictions. Check your restrictions. So in this one, Nick, what would be the restriction on the left fraction? What could I not plug in for x? -2. You can't plug in -2. So, Liam, how did he get -2? What did he do? You set the x plus 2 equal to 0, right? You set the x plus 2 equal to 0. All right, DP, what's the other restriction from the right-hand side? -1/3. And Humera, how did he get -1/3? Good job. So you're going to set each denominator equal to 0, and those are your restrictions. Okay, so I'm going to pause a moment, and I want you to cross multiply. And then what's going to happen is it's going to be an equation that's either linear, where you can solve for x. It's going to be quadratic, and we have like 4 strategies to solve a quadratic equation. The number 1 strategy is try to factor it if it's quadratic. If it doesn't, backup plan is usually quadratic formula. If it's cubic or quartic, there's probably going to be a GCF where you can factor by grouping. So we can handle all the equations now. If you're struggling to get started, here's that first step. You're going to cross multiply. I get 9x plus 3 equals 2x squared plus 4x. So then, Emma, what do you do next once I've done that?
You get everything on one side.
Good job. Get everything on one side. So then, do I want to move everything to the left, or do I want to move everything to the right? What might be easiest? Brennan? The right. Why is it right?
Because of the x squared.
You want the x squared to be positive, right? Good job. So I'm going to get 0 equals 2x squared minus 5x plus 3. All right, this factors. Now I need a 3 and a 1. And I need it to both be minus. Is it? No, that's not it. Yeah, good catch, good catch.
Would it not be -3?
Yeah, 2x plus 1.
Oh, yeah. Because I was like, wait, that's not working. That's a minus. There we go. So then that's my 3. That's my minus, and that's my plus. All right, so I get x equals -1/2 and x equals 3. Then your last step, check the domain restrictions. because sometimes you can create an extraneous solution. So I'm going to go look. X can't be -2 and X can't be -1/3. Those are not my solutions, so that's okay. So it says check the answer in the original equation. If the solution you found produces a 0 in the denominator of the original equation, then the solution is not in the domain of the equation and is extraneous. So let's use our highlighters. All right, so let's look at an example that's not a proportion. So how are you going to solve it? You've got a couple of options, but I'm going to show you what I think is the easiest. Step 1, factor each denominator. Step 2, determine the restrictions. Again, if it's not a proportion, you're going to step 1, factor each denominator. Step 2, right then and there, determine your domain restrictions. Step 3, multiply both sides by the LCD. The reason why is this clears the fractions. Step 4, solve the resulting equation. And step 5, check your domain. So this is a little bit complicated. Another option, well, does anybody think they could come up, instead of doing this, based on what we've learned, what would be another possible strategy to solve the equation? Any ideas? What else could we do? Instead of clearing the denominators, what else is another option here? What do you mean multiply the reciprocal?
To get rid of the right side.
Oh, multiply it by the reciprocal to both sides? Okay, yeah. Humira, what else?
Add to both sides and then multiply.
Yeah, okay, nice. Actually, those are both really viable options here. So what you could do is, couldn't you add these? We learned in 6.7 how to add. So if you like that, go for it. You can do it where you build a common denominator on the left and then you have a proportion. Then you're doing essentially one method. Now, Brendan, the only difficulty with multiplying by the reciprocal on that right side, the right side had both factors on the left, so that's not going to work all the time, is my problem. All right, so watch what I'm going to do. So I'm going to go through my steps. I'm going to factor the denominator on the right side. Now, it will not always work like this, okay? It's not always that the right side is the combination of the left side denominators. All right, so let's state our domain restrictions. Okay, let's state our domain restrictions. So Lily, what is one value I cannot plug in for x in the bottom?
6.
Good job. I can't plug in 6. And Elise, where did Lily get 6? Where did it come from?
From x minus 6.
Good job. It came from the x minus 6. All right, then Liam, what's the other x value I cannot have? 5. And then Hannah, where did Liam get the 5 from?
The x minus 5.
All right, good job. So here we go. So now I do this next part mentally, but I'm going to write it out once. You're going to multiply both sides by the common denominator. Now, these are really over 1. And the purpose, and again, like if you just do it in your head, then we would skip this particular step. But what's happening is now it's going to clear the denominators. So I'm going to get 1 times x minus 5 plus x times x minus 6 equals 1. Absolutely not am I multiplying, cross-multiplying. I know that it appears like that's what's happening, but that is actually, because then you're going to get burned on other problems. I am not cross-multiplying across an addition sign. Never, ever were we doing that. What I'm doing is I'm multiplying x minus 6 times x minus 5 times this one. So that left me with 1 times x minus 5. I take that LCD times here, and I get x times, the x minus 5 cancels, and I get x minus 6. I am not cross-multiplying, okay? That is not what's happening. And you'll see it on my third example. All right, I'm going to pause a moment, and I want you to solve the resulting equation.
Wait, when you multiply the x minus 5
Yeah.
times like 1 over x minus 6, how is that 1 times x minus 5? How does that?
Do you mean right here?
Yeah.
Okay, so do you see, these are my 1s, right? So the x minus 6 is in the numerator, the x minus 6 is in the denominator, so that one cancels. So this is really still a 1, and I have my x minus 5.
How come we don't cancel with x minus 5s?
I am going to cancel, so now I'm taking this whole thing, and that one's not crossed out, so I'm taking this times here, and the whole thing times that one. I'm distributing. Like I'm not sure where the question is. So let me maybe write it like this on the board, because I kind of skipped a step. So I'm taking x minus 6 times x minus 5 times 1 over x minus 6. Okay, do you see that? So that's where I'm getting the x minus 5, and then I'm getting the x times the x minus 6. Does that make sense? I'm taking that LCD times both fractions. Is that cleared up?
Yeah.
Okay. All right, so go ahead and solve that one.
It's not here. Why wouldn't we cancel x minus 5?
I did, and I got x times x minus 6.
So are we not canceling all the like x minus 5s and x minus 6s?
I am.
I'm so confused.
Okay, Matthew, what I think you're mistaking is, okay, let me go back a little bit here. If I have 5 times x minus 2, don't I take 5 times the x and 5 times the 2,
Yeah.
right?
Yeah.
So what I'm saying is you're taking x minus 6 times x minus 5 times the first fraction, so only the x minus 6 canceled, right? Then I take x minus 6 times x minus 5 times x over x minus 5.
Okay.
So then only the x minus 5 cancels, and that leaves me with the x minus 6 times the x.
All right.
What I think you're thinking is that I crossed it out here, and then I only have an x minus 5. Is that what you're thinking? Yeah. So you're not distributing. I'm saying I'm taking everything. So you can't so then what you're doing is you're only multiplying it times the first fraction. Yeah, DP?
Why can you not just cross multiply?
Because you get burned on.
We'll do the next one because it isn't cross multiplying. I'm taking x minus 6 times x minus 5 times the first fraction, and I'm taking it times the second fraction. Coincidentally, it looks like a cross multiply.
But if you cross multiply, wouldn't you get the same answers?
Not every time, no. No. We'll look at the third example together. You guys are asking awesome questions. Keep asking. So you get x minus 5 plus x squared minus 6x equals 1. So I get x squared minus 5x minus 6. So we're going to get x minus 6, x plus 1. Something I want to mention is don't lose the equation. Because you cannot solve an expression. Okay, you cannot solve an expression. So I'm getting x is 6 or x is negative 1. Uh-oh, what's our problem? Good job, good job. There's already a restriction that x can't be 6. So Gabe, why can't x be 6?
That's one of the domain restrictions.
Okay, but why is it the domain restriction? Like, what would happen if I plug 6 into the original equation? I would be dividing by 0, right? You would be dividing by 0, and that's undefined. So what's going to happen is I have to cross out x equals 6, and I only get x equals negative 1. The restrictions are from the original equation, not the simplified equation. So if what I did with clearing the LCD, if you're like, okay, I can't do that, then add or subtract on one or both sides and build a proportion, okay? Just build a proportion and cross multiply. It's just you might get into like x to the fourths, and you'll have to be careful with that. So each method has some tricky pieces to it. So all right, let's try example C. So step 1 is to factor any denominators. So my LCD is x times x minus 1. All right, then Jake, what are the domain restrictions?
X can be 1.
And what else? Well, let me back it up. How did you get x was 1? You're right, but how did you do it? All right, good job. You set x minus 1 equal to 0. So then what's the other factor? X, right? So if you set x equal to 0, what's the other one? Because, right, you're just writing x equals 0, right? So x can't be 0. All right, then what you're going to do is you're going to multiply, and this time I'm going to do a better job. I'm going to multiply every term by the LCD. And the reason why I do that is in Algebra 1, you learn something called the multiplication property for equations. And the multiplication property for equation says if I multiply the left side, I have to multiply the right side. So I have to multiply everything. I can't multiply 2 of the 3 terms inside that equation. I have to multiply everything. So I'm hoping I'll clear up that confusion we had on example 2. And then do you see DP why the crisscross on the left side won't work? Yeah. All right, is everybody with me so far? All right, so now watch. The x cancels, the x minus 1 cancels, and I have 5. I have x minus 1 cancels, I have 5x. On the right side, the x cancels, and I have 4 times x minus 1. All right, I'm going to pause and let you solve this equation. Not all of the equations end up being quadratic in factoring. This one's going to be linear, where I just have x. Do you initially get x equals 1?
Yeah.
What happens when you check the domain restrictions?
It can't equal 1.
It can't equal 1, so what's your answer? No solution. So what's going to happen is sometimes you get one answer. It might work, it might not work. Sometimes you get 2 answers, sometimes both work, sometimes one of them works, and sometimes neither of them works. You have to check your domain restrictions. All right, so let's do a little reflection here. Write down on your own, what do you think was the big idea? And flip back up at the top if you need to. How does it connect to what you already know? On a scale of 1 to 4, 4 being I'm super confident, 1 being I'm lost. And then number 4, if you didn't circle 4, what are you going to do?